You absolute legends. So I saw this problem earlier today. I haven't looked up the answer yet, but let's do it together. So to draw great Lewis dot structures, we have three criteria to consider: the total electron count, the octet of each atom, and the formal charge of each atom. So consider these two possible connectivities or structures. And I ask you, which one is a better Lewis dot structure? Let's finish out the Lewis dot structures here first. So our total electron count is 7 plus 5 plus 6 is 18. We have an 18 electron count for each of these guys right here, and everybody needs an octet. Got 18 electrons, or sorry, yes, 18 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So here they both have 18 electrons. They both have an octet. So on our first two criteria, these are equivalent structures. But I tell you that one is better than the other because of the formal charge of individual atoms. We want the formal charge of atoms to be 0 in great Lewis dot structures. If it's +1 or -1, there can be reasons for that, or there can be justifications. But for the most part in Gen Chem, we want the formal charges to be 0 across the board. So let's do the formal charge calculation for these 6 atoms here. We want every single one to be a value of 0. Let's start with this chlorine here. And to do a formal charge calculation, this is kind of our skeleton setup for the formal charge calculation. We need 3 values and then just subtract them from one another here. This first value we get from the periodic table. We find the element on the periodic table to calculate the valence electrons. We did the same thing with the total electron count. Chlorine, for the total electron count, has 7 valence electrons. So that is where we get the 7 here. Every time you do it for chlorine, this number is always going to be 7 because that's always the valence electrons of neutral chlorine. These two values here we get from the Lewis dot structure, and they're specific to the structure. So chlorine has 6 electrons in lone pairs. Chlorine has 2 electrons in bonds. 6 electrons in lone pairs, 2 electrons in bonds. So 7 minus 6 minus 1 is 0. So this chlorine has a charge of 0, a formal charge of 0. Let's go down the list to nitrogen. Remember, our goal is to have the best Lewis dot structure is going to have all atoms as a formal charge of 0 or neutral. Finding nitrogen on the periodic table, it has 5 valence electrons. 5 electrons in the periodic table. Getting from the Lewis dot structure, this has 2 electrons in lone pairs. And nitrogen has 6 electrons in covalent bonds. 5 minus 2 minus 3, that's also 0. This is looking pretty good here, this picture, because so far all of the atoms are coming out with a 0 or neutral formal charge. Again, this formal charge calculation, it's simple, but it's real easy to mess up because it's 3 terms where you're using different resources or references. Oxygen on the periodic table will always bring 6 valence electrons, 2s2 and a 2p4. From the Lewis dot structure, this oxygen has 4 electrons in lone pairs, and it has 4 electrons in covalent bonds. So 6 minus 4 minus 2, boom, is also 0. So this guy's a really good candidate so far because this candidate is fitting the 3 criteria. It has the total electron count, everybody has an octet, and the formal charge across the board is 0. Let's not rule this guy out yet, because if his formal charges across the board are also 0, we need structurally new criteria to determine between these two. Let's start with the chlorine. Chlorine, like as before, and every time you will in the future, has 7 valence electrons. In this Lewis dot structure, this chlorine has 6 electrons in lone pairs. And in this Lewis dot structure, it has 2 electrons in bonds. So 7 minus 6 minus 1 equals 0. So now let's do this oxygen. So oxygen, looking at the periodic table, has 6 valence electrons. Oxygen, looking at the Lewis dot structure, has 2 electrons in lone pairs. Oxygen, looking at the Lewis dot structure, has 6 electrons in covalent bonds. So 6 minus 2 minus 3, that equals plus 1. So that is a red flag off the bat that we have a plus 1 element here. Because we want our elements to be 0 or neutral for a great Lewis dot structure. Let's do this for a nitrogen here. Nitrogen from the periodic table has 5 valence electrons. In this Lewis dot structure, nitrogen has 4 electrons in lone pairs. And in this Lewis dot structure, nitrogen has 4 electrons in covalent bonds. So 5 minus 4 minus 2, that equals negative 1. So based on our formal charge structure, formal charge calculation of individual atoms, this is the better prediction for the Lewis dot structure of ClNO, nitrosyl chloride. Thank you very much.